The next one, find the distance between the parallel lines 15x plus 8y minus 34 is equal to 0 and 15x plus 8y plus 31 equal to 0. In the question itself, it is given that these two lines are parallel. If in the question it was not given if the lines are parallel, how can we identify the given lines are parallel or not? Check the x coefficients. X coefficients are equal. Y coefficients are also equal. The only difference is in the constant. If two equations comes like this with only difference in constant, then the equations will be the lines will be parallel. Okay, which we have studied in the class 10. So these two lines are parallel. It is already given and we have to find the distance between the parallel lines. Here also we have a formula. Distance is given by the formula modulus of C2 minus C1 divided by root of a square plus b square. What is C2 and C1? What's the general format of the equation of a line? Ax plus by plus c is equal to 0. So c is the constant. Since there are two lines, c1 is the constant term in the first equation. C2 is the constant term in the second equation. A and B are the coefficients of x and y. Since these lines are parallel, x coefficients and y coefficients remains the same. So just apply it in the formula modulus of C2. C2 is 31 minus 34 divided by square root of a square. A is the coefficient of x, which is 15. 15 square is 225 plus b is the coefficient of y, which is 8. 8 square is 64. So what we are getting 31 plus 34, isn't it? So which gives you the value 65. Modulus, already it is positive, so modulus also gives you 65 divided by this is sum is 289, square root of 289. Modulus of 65 is 65 itself and square root of 289 is 17. So we are getting the distance between the parallel lines as 65 by 17 units. Okay. Moving to the next one, Lx plus Ly plus P is equal to 0. So we have to write the equation in the form Lx plus Ly plus P is equal to 0. And here also Lx plus Ly minus R is equal to 0. The lines are parallel. Why? It is already given. Other than that, the constants are the only different terms. Coefficient of x and y remains the same. So here also to find the distance, what's the formula? Distance is equal to C2 minus C1. Modulus of C2 minus C1 divided by root of a square plus b square. C2 minus C1 is minus R. C2 is minus R minus C1 is P divided by root of a square is L square. B square is also L square. So what we get? Here we can write minus R minus P can be written as minus of R plus P. If I take negative outside, its modulus divided by L square plus L square is 2L square and is under the square root. So negative is there. When we take the modulus sign, it will be R plus P divided by L square as a square root, and 2 is not a perfect square. So we can write the denominator as root 2 into L. L is outside the square root because L square is inside the square root. Root of L square is L. So we are getting the distance as R plus B divided by root 2L units.